right?
Yeah.
And we're trying to figure out what this was,
Yeah.
right? And there's no plus sign in there,
Yeah.
is there? Okay, there's just multiplication, correct?
Yeah.
What do I get?
X squared times 2xy times y squared.
How do you get 2x? Isn't 2, I get x squared.
xy squared.
So I got x squared.
Yeah.
What else do you want me to write?
xy.
Can I rewrite them this way?
Oh. X squared times y squared.
Okay, that sounds better. And over here I have dy over dx.
Yeah.
Anything else? I want to come up with a solution, correct?
Yeah.
I want to come up with an equation where y is by itself, correct?
Yeah. So divide y squared by h.
So I got this,
Yeah.
dy,
equals x squared dx.
perfect. And then you're going to integrate.
Yeah.
Okay? Equals,
Yeah. ln of y squared.
you would not get the gong on this one.
Uh,
What is this right here?
-2.
It's a -2. Can you add 1 to a -2?
Yeah.
And you get a what?
-1.
Are you allowed to divide by a -1?
Yeah.
What number are you never allowed to divide by?
0.
0, okay? And -1 isn't 0.
Yeah.
So what do I get when I take a -1 and divide it by a -1?
1.
Try that again. 1 divided by a -1.
-1.
-1. And my power will be what?
Y.
Y. Okay, perfect. And over here I'll get what?
1/3 x to the third.
X to the third plus
C.
plus C. Super. Okay, now, we're almost in the general form, correct? But they tell us an additional condition. In other words, this graph goes to the point 1, 1, right?
Yeah.
So I want the equation of this particular graph because it went through the point 1, 1. I don't want any of the other graphs. I want this particular graph. So we're going to have a particular solution by doing what?
Plug in numbers.
Plug in the numbers what? What numbers?
1 and 1.
And 1 will go into, you're doing great,
Y.
Y, and 1 will go into
X.
X. So I get -1 on this side, would you agree?
Yeah.
And I get a 1/3 on this side, would you agree?
Yeah.
And I still have my plus C, and so I can determine that C is what?
-4/3.
Perfect. So now I have this, a -1 over Y equals, are you okay if I write it like this? I'm gonna take a few steps here. I'm gonna combine everything, since this is gonna have a denominator of 3, and this has a denominator of 3. Are you okay that I write this?
Yeah.
Alright, so now we just gotta solve for Y. I'm gonna get rid of that negative. And now I have 1 over Y is equal to 4 minus X cubed over 3. Are you okay with that?
Yeah.
Because I just multiplied those by a -1 and they just flip-flop. Okay, that's not a math term, I just made that up. Okay. And so Y is gonna equal the reciprocal, which is this. Okay, so now I'm gonna go to my machine. And my menu, I'm gonna go to my graph. I'm gonna get delete somewhere. And I'm gonna have 3 divided by parentheses 4 minus x to the third. And that looks correct, doesn't it? Ethan?
Yeah.
Okay, I'm gonna change my window because I think it is 3 to 3, right? Okay, negative 3 to 3.
Yeah.
And I don't care about this, okay, because this is going through 1, 1, which is right here. I'm actually pretty close, aren't I?
Yeah.
And when they get kind of wavy like this, I don't know about you guys, but I kind of struggle. One is because it's too little, and it's like, I take a look at how the flow is going here, and it's kind of forcing me. I suppose I didn't need to rise up there, but I would get full credit up for that on the AP exam.
Oh,
Okay? Branch, you don't have to be perfect in this class.
sounds good.
Okay. Alrighty, Walker. I don't know if I even talked to you yesterday. Alright, 2, 1 is up here, correct? 2, 1 is over here. Did you agree with that?
Yeah.
So it kinda looks like it's going this way, kinda flattens out, maybe goes this way. Kinda looks like the top part's a parabola, right?
Yep.
And you know how the bottom goes in the opposite direction? Can you see that?
Yeah.
A parabola that does that is called a hyperbola. Okay, when it reflects on itself. Okay. So get me started here.
Write an equal sign.
Oh, yes.
Good.
What?
I think that point is 1, 2, not 2.
Did I? Oh, I screwed up 2, 1. Yeah, it is 2, 1. So it must go like this.
Sideways.
Yeah, I think it goes sideways, but it can't be. I think it goes like this. I think you're right. All right, let's get back to this. I think you're right. I went 2, 1. I think I actually did this on my notes incorrectly too, if I look at it. Yeah, I got an X here. You see that? All right, equal sign Walker. Grant, again, you don't have to be perfect in here. I try to model imperfection. Okay, Walker, tell me what to write.
From dy dx on the left side, and then 2x over y on the right side.
Okay?
And then you multiply by dx and multiply by y.
Okay, so I get this.
Yeah.
Okay?
And then you integrate.
Okay?
And then you should get 1/2 y squared
Yeah? Perfect?
equals x squared plus c.
Okay. Now, what's my X?
Hmm?
What's my X? I'm gonna figure out C, correct?
Oh,
Because I want a particular solution.
your x
Right.
is 2.
So this is gonna be a 4 plus C. Would you agree with that?
Yeah.
And Y is 1 according to Alicia, and she's correct.
Mm-hmm.
So this is what here?
1/2.
1/2. So I would get a negative 3/2.
Yeah.
A negative 3/2 is, I'll write a negative 3.5, I guess.
Yeah.
So now I have 1/2 y squared equals x squared minus 3.5. Does that look right?
Yeah.
So you're gonna have me multiply by 2,
Hold on, I'm sorry.
or you're gonna
Yeah.
have me multiply by 2?
Yep.
So I get 2x squared minus 7,
Yeah.
and then I gotta take the square root,
Mm-hmm.
and it's gonna be x squared minus 7 here. What's out in front? Right here, right in
Whatever
front.
to the 2.
What?
Is it the 2?
Nope, it's not even a
Plus
number.
or minus?
Plus or minus,
And there's supposed to be a 2x squared?
yeah. Thank you for correcting me. Now, this means this is a lazy person's way to write 2 equations, correct?
Yeah.
Okay? I have to write this because I get a point for considering this equation. these equations, okay?
Okay.
But only one of them is right. And I won't get the point unless I have the right one. Which one is it? Is it the plus or is it the minus? You got a 50-50 chance, and if you look at the point, you should know.
Plus.
Plus, okay? And that's why I stopped here, correct? Because if I choose this, which is correct, or you chose this, which isn't correct, then I can't go below here, can I?
No.
I can get to 0. So it's somewhere over here. It's probably between 1 and 2. So again, I'm gonna go to my machine. Shift square root 2x squared, like you said, minus 7. Draw. And that's the part I'm looking at, correct?
Yeah.
Thank you, Alicia, for correcting me, by the way. Matt, I'm gonna have you do this one. Matt, do you have a banana every day? I do too. I have mine in one. Okay, again, we're looking for a particular solution, so we're gonna figure out C. So you're gonna have me write this, I bet, right away, because that's what Walker did. Am I right?
Yeah,
So what am I gonna do next?
you'll divide by y plus 2, and then multiply by d, or divide by dx.
Like this?
Yeah.
And then you're gonna tell me to integrate like Walker did?
Mm-hmm.
And what am I gonna get
You'll
here?
have the ln of the absolute value of y plus 2
Equals what?
e of x plus c,
E of
or
x.
e to the x
Plus C, like that, correct?
yeah.
That means y plus 2 is equal to what?
E or c times e to the e of x.
Like this?
Yeah.
And so your final answer, oh, I gotta figure out C, don't I? Correct? What's my x value?
0.
0. So, I have C e to the e power that is raised to the 0 power, correct? And over here I have -1 plus 2. And that gives me 1. Here's C. What is e to the 0?
1.
And so this is going to be e to the first.
Yep.
So 1 over e is equal to c.
Yeah.
So now I have y, I didn't even write down what I thought here. 0, -1 is right here. Is that right? We should do this right. Yeah. And so it looks like this. I'm hoping. So I got y plus 2 equals e to the ex power over e. Is that correct? I just want to point one thing out. You have a question?
Why does E go over E?
This is 1 over e. So over here I have 1 over e.
Okay.
Okay. I want to
Oh,
point
I
something.
see, okay, that's.
There you, now you see?
I see.
Even more spectacular. How many e's do you see?
I see 3 E's.
I'm just saying, every single time in the notes it happens. It is so cool. All right. So I get y plus 2. I'm just going to do this. I can say it's this. E to the x. E to the ex power times e to the -1. Would you agree with that? And even though this saddens me, I can write that as e to the ex minus 1. Now I only have 2 e's, minus 2. Yes,
If you, like, kept it in the form like ln y plus two equals e to the x plus c, and you plugged in x and y, would you still get the same answer?
yeah, we should, let's see, that's a great question. So if I would have the ln of the absolute value of a negative one plus two, correct? And that equals, too bad I made a mess here. E to the, what was, 0, correct? Plus c, right? This would be, give me the ln of, this would give me the ln of 1, correct? And this would give me 1 plus c, correct? And this is 0, correct? Equals 1 plus c, so a negative 1 would equal c, correct? So then I would have a negative 1 right here. I'd have the ln of y plus 2 equals e the x minus 1. Would you agree with that? Which means I'd have y plus 2 equals e to the x minus 1, which is what I have right here.
Great, okay.
And then I subtract 2. In fact, that might be a nicer way to do that. Sometimes I do it the longest way. I don't know why that is, it's just and usually students find a far more efficient way to do it. Okay, so I'm gonna put this, I just thought, I like this problem because e to the ex power just seems kind of funky. Okay, but that's what you can do in BC. It's gonna be a little bit more funky. Delete, so let's see what it looks like. Shift, e to the shift, e to the x. Ooh, maybe it's minus 1 right there. No, does that look right? Yeah, maybe it is. We'll find out. Yep. Oh no, I forgot my minus 2, didn't I?
Yeah.
Should bring it down. There it goes.